Good afternoon, everybody. Welcome to today's Minerals to Metals Forum. Today's discussion is on resilient mining communities, which we will be looking at through the lens of ongoing research under Minerals to Metals initiative. We will look at mine dust as well as claiming value from waste. Our panelists this afternoon are Sage Govender, Andres Motau, and Laila Ibrahim. Sage is an Earth Sciences Honours graduate from Stellenbosch University, and she is in her first year of Masters, working under Associate Professors Megan Becker and Jennifer Broadhurst, as well as Dr. Thanos Kotsiopoulos. Andres is a QES scholar with York University, and he is currently doing his PhD with the University of Cape Town under Minerals to Metal and the ACDI group. And lastly, we have Laila. Laila completed her final year Chem-Eng degree last year, and she's currently doing her master's research with Professor Jennifer Broadhurst and Dr. Yuri van Hout. We are hosting this forum supported by the Southern African Minerals, the SIM, sorry about that, the Southern African Minerals African Institute for Mining and Metallurgy. Got it right this time, thank you. Just a few housekeeping rules to get us started. During this discussion, if you have a question, please type it into the Q&A section in the toolbox at the bottom of your screen. We will address that at the end of the panelists' presentation. Please note that this forum is recorded and will be made available to the public at a later point. So if you would wish to remain anonymous, please anonymize yourself by changing your name in the toolkit section where you type your questions. If you wish to be added to the Minerals to Metals mailing list, please message me privately. And if you have any other issues during the session, please let me know via private messaging. Otherwise, that said, I will hand you over to the panelists, Andres, Laila, and Sage. Take it away. You are all still muted, I think.
Okay. I think I'll go first then. All right.
Okay.
Okay, is that clear for everyone? Can everyone hear me?
Yes, we can.
Yes, I can hear you on my end, Sage.
So good afternoon, everyone. As introduced by Dr. Moyo, my name is Sage. I'm a first-year master's student in the Minerals to Metals initiative. There I'll be introducing my research on repurposing mine waste using a mineral sands case study. So it is globally known that the mining industry produces the largest waste stream, where the waste generated is often much more than what commodity is being produced. And you can clearly see this in figure 1, where the waste quantities are distinctly higher than that of the products. These quantities and numbers, however, are continuously increasing due to the mineral demand and advances in mining technology. The pressing mineral demand also includes sand for the construction industry, which tends to be exploited and unsustainably mined in some cases. The conventional disposal and storage of solid mine waste is costly and is known to pose risks to the surrounding communities and environment. Prime examples of this include tailing dam failures, seepage from these facilities into water sources, and suspended dusts which can be carried further by winds. Additionally, this also represents the loss of potentially useful or valuable material that can be reprocessed or repurposed, simultaneously reducing the waste burden and lowering chances of long-term pollution. Globally, many applications have been explored for the various types of mine waste, which range from construction and industrial materials to landscaping. This displays the concept of a circular economy based on principles of industrial ecology, which does basically means or promotes the use of waste as a secondary resource. South Africa likewise faces this global waste problem and has explored some of the options for repurposing solid mine waste, where more focus has been placed on the coal and gold sector. However, no or limited studies have investigated the potential of such approaches and application in the mineral sands sector. The mineral sands sector is a small and often neglected sector in South Africa, despite having the second largest heavy mineral production in the world, owning around a 47.6 million metric ton reserve, as we can see in figure 2. These beach sand deposits typically contain a source of titanium in minerals like ilmenite, rutile, and leucoxene, which is just basically hydrothermally altered ilmenite, as well as minerals that contain traces of the radioactive elements uranium and thorium. These include zircons, which is a zirconium silicate, but to a greater and more problematic extent in the monazite minerals. Once mined, the heavy minerals are then separated from the beach sands, involving gravity, magnetic, and electrostatic methods of processing. Here, Motsi in 2010 has noted that the deposits only contain around 10% total heavy minerals. This leaves at least 90% to be disposed in waste storage facilities, which highlights a waste concern, as once mine waste storages have been created, it becomes a hazard that requires ongoing maintenance and care for millennia to come. And as mentioned, there are no or limited studies on mineral sand waste repurposing, except for a preliminary scoping study by Gibbons and Moran, which has already identified 3 mineralogically dominant groups from the mine waste, that being your quartz-rich tailings, clay-rich slimes of kaolinite and sepulite. And when I talk about slimes, I'm referring to very, very fine materials. This leads us to our problem statement. The conventional land disposal of solid mine wastes poses a risk to the surrounding environment and communities. This represents a loss of potentially valuable material, which could be of socio-economic benefit. The opportunities to explore alternative approaches will need to be developed on a case-by-case basis, considering both properties of the waste and other local factors. There have been limited studies on the application of such approaches, with an emphasis on risk removal in the mineral sands sector. The overarching aim is therefore to investigate potential opportunities for repurposing mineral sands mine waste, based on consideration of its physico-chemical properties and local feasibility for current processing options. A few approaches were critically synthesized in the literature review. However, I'm not going to go into too much detail with this here. The following slides showcase what literature has been consulted thus far on the popular approaches for repurposing solid mine waste in general. Mine tailings have been used as a fine aggregate sand replacement in the making of construction materials such as mortars, renderings, concretes, and cement. Trends were found based on the physico-chemical properties of the waste, which showed to be independent of their mineral operation and approach. And as you can see, most tailings were dominantly comprised of silica dioxide or quartz, a similar composition to natural sand. Other characteristics to consider in the making of these materials is the grain size and hindering effect of deleterious metals. Backfill and co-disposal is a more common approach. It has been experimentally tested to stabilize and neutralize acid-generating mine waste by introducing alkaline additives. Other characteristics to consider is the specific grain sizes, the ease of flow or slump, and very importantly, the method of disposal as a mixture or in layers. No metal retarding effect was noted, but should be considered. Bricks can be divided into 3 categories depending on the production process, that being firing, cementing, or geopolymerization. All categories rely on silica-rich tailings, with clay-fired bricks relying heavily on clay. Geopolymerization is an upcoming and greener approach that has used silica-rich tailings with no additives. The bricks are formed by compressing the mixture in a mold under a sodium hydroxide solution bath. Thereafter are dried in an oven at temperatures far lower than firing temperatures. Ceramics is also a feasible option, which utilizes silica-rich mine tailings and clay additives. Silica-rich tailings have also been investigated as moistened casting molds in the foundry industry. In this case, the silica content must be extremely high to provide the refractory properties. The clay often used is bentonite, with other clays taking a backseat. Sepiolite has been noted for its refractory properties and its smooth finishing properties, yet there are lacking studies that prove its utilization. Foundry sands have precise specifications due to the large effect of the casting part. Therefore, unbalanced grain sizes and specific impurities will lead to yield defects. And lastly, fabricated soils, which can be defined in this sense as a mixture of silica-rich mine waste substrates containing balanced amounts of nutrients, elements, and biological activity to the specific growth needs of the plant chosen. Overall, fabricated soils require intense consideration towards the amendments used for specific plants, while ensuring compatibility with the types of waste used, such as the desulfurization of coal waste before use. Deleterious metals also pose a concern over a long term, even though in some cases they are not readily bioavailable to the plants. All case studies consulted were successful, but were mostly hindered by the chemical content and economic feasibility. Some approaches seen in this table 6 require the use of many additives, which could result in heightened costs. One of the main gaps noted is the investigation into other clay types besides bentonite and kaolinite. Now, in narrowing down these approaches going forward, will require a decision support framework, or a DSF. This study field guides decision makers through a screening process of selecting suitable tools to reduce uncertainty. Eventually, alternatives become more defined and are specified in greater detail. In terms of repurposing, a study by Stander, Harrison, and Broadhurst in 2018 has constructed a framework in the identification and analysis of opportunities for the repurposing of acid-generating fine coal wastes. In 3 stages, repurposing options were identified, selected, and were discussed in a pre-feasibility assessment. This included an in-depth context-specific study around factors affecting its implementation in a South African context. These included mainly economic, environmental, social, and technical considerations. The main issues identified encompassed your local market locations, local competitor products, and pollution potential, which is what I really want to focus going forward in my framework. The hypothesis formed is stated as the ability to identify opportunities for repurposing mineral sands mine waste relies on a comprehensive knowledge of physico-chemical characteristics of each approach in conjunction with consideration of local demands and available processing options. These approaches will successfully display proof of concept when adhering to repurposing methods outlined for mine wastes with similar physico-chemical properties while contributing towards a circular economy concept using the principles of industrial ecology. In order to achieve this, there are 3 key objectives. Key objective 1 is to investigate the physico-chemical characteristics of the mineral sands mine waste. The key research questions include investigating the chemical composition, mineral composition, and physical characteristics of the waste, how the waste can be reclassified according to these, and the identification and comparison of deleterious metal content to the South African standards. Phase 1 experimental will test this by looking at the mine waste radiation, the particle sizes and shape, the chemical compositions, and the mineral compositions and clay identification. Key objective 2 will be to apply a decision support framework to aid the identification of potential opportunities for repurposing mineral sands mine waste. The key research questions were based on finding the best approach according to the reclassifications and how they can be blended together for use in a single approach. The desktop study will produce the alteration and application of a DSF, which takes into account the physico-chemical characteristics analyzed in experimental phase 1, as well as some of the technical, social, environmental, and economic considerations that are case specific. And finally, key objective 3 is to demonstrate proof of concept for one or two of the most promising opportunities for repurposing mineral sands mine waste. The key research questions were based off how the products compare to local industry standards and what percentages of tailings need to be used in the shortlisted approaches. Phase 2 experimental needs to be developed actually further as it looks at the specific procedures of the approaches. And this can only be done once the DSF is completed. So in a nutshell, why should we bother about this research? Waste is problematic and it will continue to be stored for millennia to come. We therefore need to start viewing it as a secondary resource. Why mineral sands is of interest is that this sector in general lacks in repurposing waste research. It does, however, seem to have potential for this due to the waste's dominantly sandy silica quartz compositions, and this is good for use in most approaches. And finally, the impacts of this research will result in the reduction of waste storage and its associated effects, the potential creation of further downstream industries, and will therefore contribute towards a circular economy concept. Thank you. Questions?
Thank you very much, Leila. Sage, sorry. We will take questions at the end of the entire session. For now, we will just move on to the next panelist, that's Andres. For anybody who's got questions for Sage, please type them in the Q&A box and she will respond to them at the end of the presentation. Or raise your hand, I'll take a note of it and we'll refer back to you when the final panelist is done talking. I'll hand over to Andres for his presentation.
Thank you very much, Thandazile. I'm Andres Molatalumtau. I'm supervised by Professor Jennifer Broadhurst and Iska de Groot from the African Climate Development Initiative, ACDI. So I'm looking at the conflicting perspectives in the Global South Just Transition movement and using Mpumalanga coal region as a case study. So when it comes to the background of my study, we all know that the South African coal mining sector has evolved over the years, and coal has played a significant role or has had significant impacts when it comes to the social, the economic, and the environmental impacts in South Africa. Coal contributes to South Africa's energy needs and contributes to the support of many sectors, even in the petroleum, to companies like Sasol as well. But then coal mining utilization have been linked to many negative legacies. One of them being that it has fostered inequality and poverty within South Africa, especially in coal regions. If you go to places like Mpumalanga, Emalahleni is still ranked as one of the most unequal places, or places that is one of the places that has high poverty rates in South Africa. And though it still produces it's one of the leading producers of coal mining in South Africa. So, and also other negative legacies that are linked to coal is the fact that it is responsible for environmental degradation, and it contributes to climate change as an issue. In South Africa, they came up with the National Development Plan in 2012, and with the National Development Plan for 2030, in their chapter 5, they vowed that they want to create an environmentally sustainability and equitable transition to a low carbon and climate resilient economy and society. And this is implementation of moving South Africa from an economy that is reliant on fossil fuels to an economy that is much more cleaner energy. But then within this, they never stated a just transition. They just stated an equitable transition. And this has fostered many questions on what does a just transition mean in the context of South Africa. But then before I get into what does just transition mean in the context of South Africa, one needs to go and explain what is the just transition. A just transition emerged in the 1990s in Canada, and it came from trade unions. At the beginning, it was the move from fossil fuel related jobs to green jobs. But then over the years, the concept or the term has been broadened. It has been broadened to include the environment and other aspects. But then in South Africa, a just transition is still a bit complex to understand because then it has many actors. Everyone defines it according to how they understand it. Trade unions see it as a transition for jobs. And then civil society sees it as a transition from fossil fuels to a more cleaner energy. And obviously businesses see it as a transition to coal mining companies. They also see it as a transition from not using new technologies to mine better and to decrease fossil fuels. So there are many different perspectives and agendas in regards to what a just transition means in South Africa. So now it leads me to the problem statement. Many countries in the world are moving and implementing policies for a just transition and a fair transition to a climate resilient and low carbon economy. Whilst there is a general pressure on the need for South Africa to transition from a coal-based to a low carbon economy in the manner that is just and equitable, there's a different interpretations of what this entails in practice. This is aggravated by the different priorities of various stakeholders and the potential contradictions that might arise from simultaneously pursuing ecological, political, social, and economic objectives. Despite these many conflicting perspectives and agendas, there's still no clear pathway on how a just transition can be achieved in the context of South Africa. So hence the reason one is conducting this study, just to look at the different stakeholders' perspectives, their discourses, tensions, and synergies in the just transition debate. And at the end, one is hoping to develop a framework in order to achieve a just transition in South Africa or in the Mpumalanga region. So the overarching aim and rationale of the study is to identify and analyze different stakeholders' perspectives, discourses, tensions, and synergies, and within the just transition. And using a multiple streams framework, and this is just to apply an understanding in the development of a framework to guide the implementation of a just transition. And this will be done using a multiple streams framework, as I have stated, and it's in combination with other different methodologies. And ultimately, the study sets out to facilitate an inclusive low carbon economy in South Africa. So when it comes to literature, the literature has been viewed from the environmental and social impacts of coal and its contribution to climate change in South Africa. So I'll start with some of the impacts, the environmental impacts of coal. So one is that it's a source of pollution, and the pollution occurs through blasting, wind erosion of exposed areas, and emissions also occur during transportation and handling of coal in mines. And this comes from Anya. And coal, in regards to Mpumalanga has been declared as one of the priority areas in terms of Section 18 of the National Environmental Management. And this is due to high emissions within the area, some from coal mining and some from coal production. Other negative impacts of coal mining come from its impacts on water. It's believed to contaminate water and cause disturbance to amounts of land and destruction to wetlands and rerouting of water. And this is found in Glen Hayes, Bell, and McCarthy. It's widely covered on the impacts of coal mining and coal production and acid mine drainage are widely covered in literature. So when it comes to the social impacts of coal, it is believed that it damages homes, and this is due to its blasting that occurs when it's mined, and also damages to infrastructure, large vehicles that go into the mines transporting coals, and unplanned removals. Sometimes mines are found and communities that are nearby, they are forced to be removed so that mining can occur. can occur. And the Center for Environmental Rights covered this widely in their reports. Also, Shongwe states that coal mining can have detrimental impacts on crop and livestock farming. Also, through it, there's been increasing rebellion and tensions and conflicts. And one good example of this is the Mabola Protected Area, which there was a rebellion from civil society that coal mining must not occur there, since all is a protected area. And I think the civil society was able to win one of those cases. Also, another rebellion was the Kruger National Park. There was a proposed coal mine there, and then civil society came together and other different stakeholders where they were rebelling against it. Coal mining is also believed to cause climate change, to contribute to climate change. And this is due to the gases that it produces through its utilization and production, and emissions such as methane and carbon dioxide, as well as indirect emissions through its consumption of fossil fuel-derived electricity and other materials. And this is covered by Pendy and Strambo. So in literature, since one is looking at the complexities and different agendas and perspectives, it is important to look at the discourses, because then complexities, they come with discourses. So discourses are sets of meaning, and they define power relations, and they can create subjects and objects through practices. So one discourse that has emerged in Germany when it came to a transition, it was the energy transition discourse, and this particular discourse showed that it can be discourse can be politically hegemonic, as there's competition within them, and the one that is much more favored, it becomes dominant and has the capabilities to undermine and influence power. Also in Australia, we've seen that coal mining had a hegemonic, discourse when it came to public policy and conflicts. And this is covered by Evans and Pillan, and this is within the energy transition discourse. Civil society discourse, there's also the civil society discourse. Civil society discourse often states that climate change is happening. They argue for climate change, that climate change is happening and transitions should occur as soon as possible. While other stakeholders like trade unions says that, well, we do acknowledge the need to transition, but then jobs cannot just be we cannot just transition, we have to take care of jobs first. So there are those contradictions within the discourses. So as I've stated, civil society, there's been a lot of work, a lot of protests, and a lot of social movements across the world. In the UK, we've seen social movements which mostly were anti-coal campaigns, as well as anti-coal mining campaigns, and as well as the famous one, the End of Coal, which was an end of coal mining campaign in Germany. And this is stated by Weber and Cabras. In South Africa, the protests, or should I say the campaigns, normally they discourage the development of new coal-fired power stations and mines, and the support and the reduction of emissions from existing coal infrastructure, and encouraging a coal phase out. And this is seen from the Life After Coal campaign is one of them. And it's one of them, and Munich states about this. Even the Life After Coal campaign, they have documents that they have published in regards to going away from coal mining and coal production. However, Bonn states that environmental groups in South Africa, they are not as militant and effective. And he does this by comparing South Africa's movements with the Germans and the Geland. And Bonn states that, well, we can speak about a just transition, but then it will be, civil society in South Africa is not as strong as others. So in dealing with the complexities and the different viewpoints or perspectives in addressing, in coming up with solutions to a just transition in the context of South Africa, one has realized that a just transition cannot just be achieved by being viewed from a single lens. A just transition can be achieved by using transdisciplinary research, TD research as it's known. And then TD research is about combining different fields. It's about different fields working together. It's about the sciences, the natural sciences, the social sciences, and the societal factors, your banks and civil society and communities, ground roots communities working together in order to find societal solutions to societal problems using multiple forms of knowledge. And then when applying a transdisciplinary research, we're using all these stakeholders within, the aim is to co-produce knowledge and solve complex social and ecological problems. To solve complex social and ecological problems. So transitional research is important in getting what different actors think of a problem and how we can use that different lenses to address complex problems. And complex problems, I'm referring to problems such as just transition, where there are many actors within them, problems such as climate change, where there's different people that view different people with different lenses when it comes to it. So now from co-producing knowledge and solving these complex socio-ecological problems, one aims to also use a socio-technical transition. And a socio-technical transition is a transition that involves a shifts that occur when a socio-technical system changes to another as a result of interaction of a social and a technical dimension in a particular moment in time. And this is mostly from technologies that are used in the mining sector currently. How do we shift from them and move to new technologies such as new renewables and your solar panels? However, it is important to state that using both the transdisciplinary research and the socio-technical transitions as framework or theories that guide this research, one needs to have a nuanced understanding of how the coal mining sector or the coal mining system and its path dependencies, the things that are locked in, the practices and ways of doing things, and continue to drive the system. So one needs to understand what drives the system, how can the system change, and this will be done by understanding the governance of the system, and the governance of the system is who the key stakeholders are within this system, and what practices or ways of doing things are there, and what are the actors thinking, and what policies and legislation and technologies and practices are there that they are using to achieve their goals. So since I spoke about government systems, the governance systems, they'll come in the form of governance configuration dimensions, and government configuration dimensions, they have 6 parts. So you look at the actors and the networks, you look at the discourses and policies and institutional mandates and material reality, including material products, technologies, and infrastructure, and decision-making process, both formal and informal, as well as the situation-dependent place-specific contingencies. And this comes from Broadhurst and Broadhurst and Scott. So now, since one is using transdisciplinary research as a transdisciplinary research and socio-technical transition as a guiding framework to achieving this, but then in terms of understanding a just transition, policy also plays a critical role. How do we shift from the current policy to creating a new policy for a just transition, and helping to analyze and coming up with the solutions to the problem that has been listed? Also, one will apply a multi-streams framework, and multi-streams framework is also about looking at the problem from different streams, the problem stream, which in this case will be the discourses and the tensions, and also the policy stream, which is the current policies that have been proposed and future policies that, or alternative policies that have been proposed, as well as actors. Who are the elected actors within the different stakeholders, and what are the actors saying? Also using this to come up with a window of opportunity so that one can have a clear guidance of on where to go. So from the transdisciplinary research study, from transdisciplinary research and the socio-technical research, coming from the governments and configurations, one wants to look at the levers of change, and one wants to look at the levers of change, and this needs to be, this needs to be well understood for one to identify on how such a transition can occur, or how such a shift of a system to a socio-technical transition can occur. So these frameworks they are the ones that have guided the research questions and objectives for the study. And one of the objectives being that to analyze current discourses, interrelationship, tensions, and synergies between different stakeholders in relation to both coal mining and coal-based power generation. What are the current discourses between different stakeholders in relation to both coal mining and coal-powered generation? Which discourses are dominant? And how are they influencing other discourses within the just transition? How is the media discourse framing coal mining and just transition in the context of South Africa? And what are the drivers from both the pro and anti-coal lobbies for a just transition? Another discourse is to identify the dominant actors and their roles and their ability to effect change in climate policy and practice. And this will be done by asking questions on who are the dominant stakeholders within the just transition, and what influence do they have on the climate policy and practice? What is the role of civil society and its success in effecting change in policy and practice in coal mining? And how can civil society effect change better in climate policy and practice? Overall, one aims to develop a framework that can guide the just transition using the complexities or problems that are found within it. And this is one of the objectives to develop this framework to facilitate a just transition. And the questions being that how can these stakeholders, discourses build interrelationships and drive tensions and synergies from both the pro and anti-coal lobbies? How can these discourses, interrelationship, tensions, and synergies be used to inform a framework implementation to achieve a just transition? Since the main driver framework of the study is a transdisciplinary framework. With transdisciplinary framework, one can either choose to do a qualitative study or a quantitative study, but however, for the sake of the study, since all these many stakeholders and different stakeholders, it will be a qualitative research. And then Mpumalanga, the Mpumalanga coalfields have been selected as a case study design, as a case study, okay, as a case study and exploratory design. So I'll be using interviews and desktop research and observations to collect data. And for my data analysis, I'll use discourse network analysis, since well, I'm dealing with different stakeholders, and it categorizes text and codes informations into statements. And from these statements, you use a software to come up with network of actors. And from this network of actors, one can see the coalitions and clusters. And an example is there at the top right corner. Also, another data analysis method that one will use is of document analysis. Document analysis is just to get a background on what has been said, what has been published, what has been written in public about the just transition and how it can be achieved. So in conclusion, the demise of coal is inevitable. Many countries in the world are moving away from coal. And it is important that when coming up with solutions in South Africa, that solutions should not come from a single lens, but should come from different lenses. And this can be done using a transdisciplinary research. Often we've seen how South Africa has evolved over the years, and poverty and all other things and all other social issues that have arisen in South Africa Now we are given with a chance to have multiple stakeholders work on a different problem to come up with the solutions that can benefit South Africa. So it is of importance for one to conduct the study to understand how we can achieve a just transition that will be beneficial for the country and its people, especially the people at ground roots. Thank you.
Thank you very much, Andres. And once again, I would ask you to type your questions in the Q&A box while we move on to the next panelist, Leila Ibrahim. Leila will be speaking to us about mine dust. She is doing an MSc project assessing the distribution, composition, and potential human health implications of particulate matter in Saldanha Bay municipality. Leila, you are welcome to share your slides and go ahead with your presentation.
Okay, give me 1 second. Oh, I don't know what's going on with my laptop.
You support the right team, don't worry. While we wait, we can celebrate while we wait.
I'm so sorry, I don't know what's going on. Okay, there we go. Right, can you see my screen now?
Yes, we can, thank you.
Okay, good afternoon, everyone. Today I will be presenting my project proposal. So it has been approximated that about 7 million people die due to air pollution globally. These premature deaths result from the combination of both ambient and household air pollution and largely result from underlying medical conditions such as heart disease, lung cancer, and acute respiratory infections. The World Health Organization reports that 9 out of 10 people breathe highly polluted air, and nearly 91% of the world's population live in areas of extremely poor air quality. So, air pollution can be caused through natural phenomena. However, with increasing industrial developments, it has been found that anthropogenic activities also contribute significantly towards the pollution of air. Continuous mining operations such as port loading and unloading activities, as well as the transportation of bulk minerals can be classified as anthropogenic activities, which contribute significantly to the inadvertent contamination of the environment and the surrounding communities. Major air pollutants that arise from mining operations include particles that have an equivalent aerodynamic diameter of less than 10 microns and 2.5 microns, which is PM10 and PM2.5 respectively, and total suspended particulate matter. Such pollutants are known to reduce the quality of air and cause adverse health effects on the surrounding communities. This study involves assessing the distribution, composition, and potential human health implications of particulate matter in the Saldanha Bay municipality. The presence of the Transnet port and other industries have resulted in the transportation of different types of metal ores through the Saldanha Bay municipality. These metal ores are transported in uncovered wagons, handled and exposed to the atmosphere by being stockpiled in open yards until exportation. Although the available data from monitoring stations have indicated that levels of particulate matter in the air are within compliance, incidences of exceedances have occurred and significant gaps in data collection is a problem. And no further analysis has been carried out to identify the concentration and composition of the fine particulate matter or to assess the potential health implications. The aim of the study is to assess the potential health-related effects associated with inhalable metal-bearing particulate matter in the Saldanha Bay municipality. The first objective is to determine the receptor sites to carry out sampling across the Saldanha Bay municipality. The second objective is to collect, generate, and analyze particulate matter samples for elemental composition and concentration. And the third objective is to provide a preliminary indication of the potential health implications from the analysis of the samples. It has been reported that impacts of dust on the environment are due to both airborne and non-airborne particulate matter. Dust is generically defined as fine particles that are suspended in the atmosphere and can be subclassified with regards to its effect on the environment and human health. According to literature, some elements have been found in trace amounts in cloud, fog, rain, and snow, with mining activities alluded to as the sources. Specifically, PM10 levels have been reported to reduce the quality of air and visibility and play an important role in the climate of the region. With regards to this study, there has been an increasing awareness of the spread of red dust from the iron ore transportation and handling. So the size and shape of a particle are the two critical factors which control the extent to which airborne particles penetrate the respiratory tract in humans. Inhalable, thoracic, and respirable dust are the three subclassifications under health effects. Inhalable dust is defined as dust that is breathed in via the nose or the mouth and is therefore able to settle anywhere along the respiratory tract. Thoracic dust is a portion of the inhalable dust that penetrates the head airways and enters the airways of the lung. The size range of these particles are less than equal to 10 microns. Respirable dust, however, is defined as the fraction of dust that penetrates the gas exchange region of the lungs. These are the finest of particles, less than 2.5 microns, and are capable of reaching the alveolar region. It is also reported that the finest of particles deposited deep in the lungs can be transported into the bloodstream. Saldanha is a picturesque coastal town, situated on the northern corner of one of South Africa's largest natural bays. The ideal location of the bay attracts both local and international water sport enthusiasts. The port of Saldanha is South Africa's deepest port and is regarded important for economic growth along the west coast. The port was built in the early 1970s for the export of iron ore, with the very first shipload exported in 1976. By this time, the Saldanha Bay Harbour became an international port and could accommodate large ore carriers. Today, various other mineral ores are exported, such as manganese, lead, and zinc. The handling facility at the port has the capacity to export 60 million tonnes per annum of iron ore. However, as of recent, a request was put forward to increase this amount to 80 million tonnes per annum. There has also been requests to expand the multi-purpose terminal, which currently stores 90,000 tonnes of ore in two sheds, and proposes to store an additional 200,000 tonnes in open stockpiles along the quayside. The development of the port has resulted in rapid urbanization in Saldanha Bay and Langebaan. Although this results in the boosting of both the regional and national economy, some of the controversies faced are the discoloration of houses and buildings in the surrounding communities and incidences of metal exceedances at the monitoring stations. A previous study was conducted around Saldanha to determine whether the presence of industrial and metal producing activities contribute to the overall metal contamination levels in the soil. More importantly, the study also highlighted the potential sources of metal dust emissions in and around Saldanha. The sources include both Transnet terminals, ArcelorMittal Saldanha Works, Tronox Namakwa Sands, Deferco Steel Processing, Lafarge Saldanha, and VDM Transport and Handling, and are indicated in Figure 7. Table 1 presents the potential contaminants that each source emits. Although ArcelorMittal has stopped all operations at their Saldanha plant, they are listed as a potential source due to the activities carried out in the past. The study concluded that the presence of these activities have resulted in elevated metal contamination levels in the area. However, this study will not be investigating the effect that climate has on dust exposure, but the results obtained by this previous study indicated that the dispersion of the metals from the emission sources were in a predominantly northwesterly wind direction. Since the 1970s, there have been a number of attempts made to quantify the accuracy and precision of respirable dust measurements, and majority of these studies involved the use of inadequate equipment or a reliance on data that had been originally obtained for other purposes. And this had resulted in estimates of uncertainty confounded by uncontrolled factors. Therefore, it is important that reliable samplers or sensors be used while conducting air quality studies. So figure 8 indicates the sampling sites used by the Saldanha municipality. Although there had been measurements of metals within compliance, there has been incidences where metals such as lead has exceeded the limits. There are a total of 9 sampling sites. 2 of them are air quality stations and the other 7 sites are dust bucket sites. Considering the area of study, it is important to note that the composition of the ambient dust samples can include other particles from various sources. Depending on the climate and meteorological conditions of the area, high variability in the characteristics of the collected samples can occur. And this variability poses a challenge when integrating results from different studies. And therefore, there are different approaches that have been taken to capture and analyze particulate matter samples from mineral materials in a laboratory-generated settings. It is important to determine both the chemical and physical characteristics of dust particulates in order to identify the contributing sources and the potential health-related implications. However, there exists no single technique that can provide all the necessary characteristics with regards to mineral matter. And to obtain a complete understanding of the dust particulates, it is important to integrate data from different sources. Table 2 indicates the South African and international guideline values for metals that are transported through and exported from Saldanha. So the National Environmental Management Air Quality Act outlines the South African guideline values for both PM2.5 and PM10 daily and annual limits. And these standards allow for 4 daily exceedances. However, iron, manganese, lead, and zinc are not listed in the Act, and therefore international standards were taken into consideration. It is postulated that the transportation, handling, and open stockpiling of the metal ores, in addition to the activities of multiple metal-producing industries, contribute to the elevated levels of inhalable metal-bearing PM2.5 and PM10 across the Saldanha Bay municipality, which can potentially have negative health implications on the surrounding communities. The key questions for this study are: what are the concentrations of particulate matter at the receptor sites? What are the chemical and physical characteristics of the collected particulate matter samples? Based on the results of the analysis, what are the sources that contribute to the particulate matter concentration? And based on the results of the analysis, what are the potential health implications? So this study consists of 3 aspects: the desktop, fieldwork, and lab aspects. For the desktop study, review of published data on air quality and in general will be, published data will be reviewed. Interviews will be watched and carried out with the municipal air quality officer regarding the controversies in the area. Past studies that were carried out based on air and soil quality in Saldanha will also be consulted, and further research will be conducted on the different industries in the area and combined with data from previous studies and interviews. This part of the study also includes determining the receptor sites to install the dust sampling equipment. In addition to the receptor sites, sampling will also be carried out at the 2 air quality stations to compare the data that is obtained. The fieldwork study includes installing the sampling equipment across the municipality. The 2 types of equipment that are considered are optical particle sensors and low-cost personal particulate samplers. So OPCs, the optical particle sensors, provide fast and online measurements, and the advantage to using personal samplers is that they are low cost and they're already in wide use across many industries for the sampling of airborne contaminants. It has also been reported that when compared to other sampling methods, personal samplers are preferred to assess personal exposure. The sampling will be carried out according to the South African reference methods, EN 14907 for PM2.5 and EN 12341 for PM10. The fieldwork study also includes the collection of the data and samples to be brought back to Cape Town for analysis. The lab study includes generating dust from ore samples, and this is done to account for various other contaminants such as sea salt aerosols, since the study will be carried out on the West Coast. Both the generated dust and the dust samples are required to be analyzed to determine metal constituents and whether or not limits are being exceeded in the area, and what the potential health effects would be by inhaling this metal-bearing particulate matter. And the two methods that would be used are ChemScan and ICP-MS. The results of metal concentration that will be obtained will be compared to the South African and the international guideline values to determine which are within limits and which have exceeded their limits. And due to the COVID-19 pandemic, fieldwork has been postponed until further notice. So as of right now, I am busy with my desktop study. Thank you.
Thank you very much, Leila, for that. We have had 3 presentations this afternoon under the theme Resilient Mining Communities, and we have a couple of questions that we will try and attend to in the remaining 5 minutes of our session. So the first question I will ask Sage to respond to a question. Hi, Sage. Thank you for the informative presentation. You mentioned that current practice is to store waste sands permanently. Will this method of storage pose a challenge to accessing the waste and treating it, e.g. sealed landfills in the future? Sage, if you could respond to that question and give your closing remarks in 1.5 minutes.
Okay, so yes, definitely, but I'm actually not looking at landfills, rather these residue storage facilities or tailings dams. It is one of those hurdles that we need to consider when extracting the mine waste from these dams, but if we can take the waste straight from the processing plants into creating the approach, then it obviously will be a lot easier. Right now, the challenge of slimes is hindering the sampling process because they're so fine that heavy machinery sinks into it. So yeah, it just becomes very hard to sample. So yes, good question. It is a big thing to consider.
Okay, thank you, Sage. So the next question, which I will bundle up into a 1 answer slot for Andres. One is from Petrus. He says, banks, investors, and international mining companies are under pressure to disinvest from coal. Will that not force a transition onto the coal and energy industry that overrides any conversations that greater society is having to try to negotiate a soft landing on? And also, while looking at that, Andres, please respond to from Maboko, who says, Andres said the demise of coal is inevitable. When will the economy start noticing this?
No, thank you very much, Ndazile, for the questions. I mean, the banks form part of all the stakeholders within the just transition, and it's a heavily contested environment. So a soft landing would be very difficult for them, even though there are pressures to disinvest and then they have money. But then it still goes back to the communities within the spaces where transitions need to occur, are spaces that are highly contested. You find a civil society that is arguing against them, and trade unions. So it's I don't think they will have, even if they are investing money or disinvesting money, they'll be able to override what's currently happening. And also banks, they disinvest, but then they invest in other fossil fuels. So it's just a trade-off when it comes to that. And the last question was the demise of coal. I mean, the demise of coal is inevitable in the sense that we're seeing in developing countries that it's moving away. People are moving away from the use of it, and countries like Australia, Germany, and others. So in South Africa, it will happen, but then in South Africa, it might take a lot longer than expected, probably in the next 40 years. Yeah, thank you, Thanos again.
Thank you, Andres. And then Leila, you have a question from Harold. How will you determine the potential health effects or industry AQ limits are not applicable for ambient public exposure? Use of arbitrary factors to reduce industrial limits result in arbitrary results. And while on that, Leila, I will urge you to take a note of Alex's comment. We will not, I don't think you need to respond to that, but just take a note of the reference number given to the study he is citing. If you could take a minute to answer and we wrap up.
Okay, thank you for your question, Harold. So for my study, I'm not going to be doing an in-depth health risk assessment. So I would, like my idea right now would be to look at, well, when I do carry out my sampling, I would look at the results and obviously just see where's the outliers, which metals have given me outliers, and based on those levels of that particular metal, I would give the potential health effects that, you know, people would maybe suffer from or be affected by. But that results could be used for an in-depth health risk assessment. So it's just looking at what those metals can do to humans over a prolonged exposure. I don't know if that answers the question. And thank you
very
Alec,
much
for your suggestion. I will look at that. Thank you.
Thank you very much, Leila, and thank you to all our panelists, and thank you very much to you, the audience, for joining us this afternoon. It's 3 o'clock on the dot, and we should be closing off this meeting. We look forward to you joining us again next week. For videos of those presentations, please visit the Minerals to Metals website and find the link to our YouTube channel. You will find recordings of this and the previous forum recordings. We look forward to hearing from you again next week. You joining us rather next week on Wednesday. Have a good afternoon, everybody. And thank you very much to the SIMM for hosting us. From myself and the rest of the Minerals to Metals team, standing in for Aisha Lota, thank you. Cheers.